Welcome to my presentation. Please place your eye to the centre of the screen. Access granted. This mission will include me, Miss Whitelaw, otherwise known as the teacher, and I'm on a mission. To find out if science and maths should be taught with a cross-curricular approach or as discrete subjects. Also the impact of ICT. But first we need to ask a question. What does cross-curricular actually mean? According to Collins Dictionary, the literal definition of cross-curricular is denoting or relating to an approach to a topic that includes contributions from several different disciplines and viewpoints. Barnes explains that our experience of the world is cross-curricular. Everything that surrounds us in the physical world can be seen and understood from multiple perspectives. For example, as adults we tend to perceive features of the universe from a variety of more or less experienced viewpoints. The innocent eyes of the child have probably always seen a different world to that of their parents. Jacobs explains that most definitions of cross-curricular work, which is also known as curriculum integration, emphasise how combinations of subjects are used within project or thematic work. This links to the general consensus from Hayes' viewpoint that cross-curricular approaches are referred to as interdisciplinary because it incorporates more than a single subject area. Fogarty describes cross-curricular using 10 ways to integrate the curriculum. He explains cross-curricular as roots running underground whereby contrary and remote things cohere and flower out of one stem, as the mission of both learners and teachers. He also states that to the young mind everything is individual, stands by itself. By and by it finds how to join two things and see them in one nature which continues to develop. This is through the following 10 models which present ways along a range of approaches to accomplish integrating the curriculum. It is important to acknowledge the record of legislation and shift to where we are today in regards to cross-curricular, as it has been the subject of debate for a considerable period of time. Within primary education, this has been associated with a more child-centred, constructivist approach, which has been emphasised within the Haydow and Plowden reports. Firstly, prior to the implementation of the national curriculum in 1923, the Haydow report recognised recommendations within schools that curriculum subjects should be more closely interrelated. Then, in 1967, the Plowden report promoted flexibility within the curriculum, debating that learning does not fit into subject classifications completely and that there should be more freedom across the subjects. Furthermore, in 2009, Sir Jim Rose directed the independent review of the primary curriculum. The Rose Review was commissioned to address the concerns that the current national curriculum is too prescribed and, as mentioned before, content-heavy. It was concluded that although subjects will remain in their own right, the current national curriculum subjects ought to reside within 6 areas of learning. Significantly, cross-curricular teaching is to be fostered to strengthen the 6 areas. Finally, the current national curriculum is explained as just one element in the education of every child. Also that there is time and space to range beyond the national curriculum specifications. This includes teaching staff developing lessons that are stimulating and exciting. Its structure favours the approach of Rose in enriching cross-curricular studies. In relation to theorist views linking to teaching through cross-curricular or discrete manner, Jerome Bruner believes that the intelligent mind creates from experience. Therefore, children as they grow must acquire a way of representing the repeated consistencies in their environment. In his research on the cognitive development of children, Bruner proposed 3 models of representation, one of which is the theory of inactive learning. In order for a child to progress, they must actively take part in the learning process so that the skills can be acquired. Another theorist to consider is Jean Piaget, who understands that children process through a series of 4 critical stages of cognitive development. Also, that children are like little scientists. They must be an active participant in their learning in order to assimilate the knowledge and then adapt it into a real-life context. We will now look at the principles of cross-curricular, including the pros and cons and the discrete approaches to maths and science. Kelly and Steed investigate the debate of child-centred progressive teaching against traditional discretely taught lessons. It is argued that the child-centred approach allows the child to make sense of the world in which they live. On the other hand, the traditional approach of teaching lessons discretely only places emphasis on the essential knowledge the children need to learn. Linking the consideration within the Plowden report that children's learning cannot fit easily into subject categories was the adoption of thematic and topic work approaches to curriculum delivery. These approaches attempted to integrate a number of subject areas so that they were studied simultaneously, with the knowledge and skill essential in each subject area being brought to stand upon a problem or a clear sequence of problems in order to find a solution. Therefore, if the problem or problems identified were real ones, they were unlikely to be solved adequately within the limited context of discrete subjects such as science alone or maths alone. Where selected real problems relevant to the pupils' environments or interests, then the ideas and methodology together with those from other subjects needed to be used. For example, in order to bake a cake, children acquire measuring skills to use the correct amount of ingredients, and also working scientifically skills such as the ability to recognise differences, similarities and changes related to simple processes. Whereas in discrete lesson format, to solve a problem such as measuring ingredients or recording matter of change, similarity or difference of the mixture's consistency, a solution would more than likely not be made due to the skills not being applied to real life or in an engaging way. As well as this, in Ofsted's report on creative approaches to raise standards, it is clear in key findings that pupils who are supported by good teaching that encourage questioning, debate, experimentation, presentation and critical reflection enjoyed the challenge and had a sense of personal achievement. The confidence they gained encouraged them to develop and present their own ideas with greater imagination and fluency. Approaches developed successfully in traditionally creative subjects and were often incorporated into other areas, such as science and maths. Fisher and Williams support this by stating that cross-curricular work can strengthen creative thinking, which therefore produces more creative work. Yet Hayes pinpoints that when referring back to Rose's official commendation of cross-curricular teaching, there may be less enthusiasm when the practicalities of planning and implementation have to be addressed. It is questioned that learning needs the clearly defined boundaries provided by single subject teaching. However, Rose does not advocate in eliminating such boundaries. It's also argued that an integrated approach is insufficiently rigorous, especially in ensuring that children have regular opportunities to gain fundamental skills in key subjects. Coinciding with this, Greenwood carried out a key research study which discussed teachers' concerns to subject-based and cross-curricular approaches. The study revealed that many of the respondents had reservations against a cross-curricular approach to teaching. Among the worries expressed was a fear that by delivering individual lessons by project-based study, subjects may be forced together. Many teachers believe that this could lead to links being found by subjects that aren't naturally there, and the relationships between the subjects being more forced. As well as this, an important area to address is the implications with regards to assessment. Rowley and Cooper's view acknowledges that by linking the subjects, some teachers feel they cannot meet the school's policies in assessment in the discrete subject areas. It is appropriate here to introduce the specific cross-curricular relationship between maths and science. The National Curriculum 2014 states that within the maths purpose of study, maths is a creative and highly interconnected discipline. Also indicated is that it's essential to everyday life and critical to science. In its aims, it highlights that pupils need to be able to move fluently between representations of mathematical ideas. This includes applying their mathematical knowledge to science as well as other subjects. Alongside this, science within the national curriculum positions that pupils should apply their mathematical knowledge to their understanding of science, including collecting, presenting and analysing data. This interlinks with the skill within maths that children should be taught to interpret and construct simple pictograms, tally charts, block diagrams and simple tables. For some children, maths and science are exciting subjects that work side by side, one providing the opportunity to practice and improve skills and knowledge gained from the other. The PPLATO agree by stating that nearly all courses in science will assume some mathematical skills and techniques. There are multiple examples of activities that include maths and science skills and how they can be successfully delivered in a cross-curricular way. For instance, measurement, where in the national curriculum it states that children should be taught to measure in the following. These principles are reiterated within the science curriculum, where it is stated that children should be taught to make systematic observations and take accurate measures using standard units. Referring to Rose, Bruner and Piaget's views that by children being an active contributor to learning, they will form a greater understanding of the skills and be able to apply them in other contexts. This is shown in a classroom activity when children were each given the tools to plant their own seed. Over a 2-week period, they recorded how varying amounts of water in millilitres affected its growth in centimetres. However, science and maths are two distinct disciplines, each having their own characteristics. Maths distinguishes itself from science in respect to the concept of being certain. Maths problems imply that there is a solution, and the process of problem solving is the search for certainty. ICT as a curriculum subject is rapidly becoming a means to facilitate learning in other subjects, including science. Suggested changes to the national curriculum made clear that ICT should not be taught discretely but also embedded within all of the other subjects. The TDA pinpoint that ICT is increasingly becoming part of our daily lives. Finally, the following are various forms of ICT used within maths and science. Living in a world where technology is constantly developing, ICT within subjects can promote and ignite learning. To summarise, should maths and science be taught in a cross-curricular manner or as discrete subjects? Many views agree with teaching in a cross-curricular approach and discuss it's a successful model. Pedagogical discussions state that there should be a balance between cross-curricular and the subjects being taught discretely. Barriers such as teacher confidence and knowledge of understanding can be overcome by continued development and teacher support.